This is question number 6 on page 465 of Giancoli's 6th edition. It reads, two charged dust particles exert a force of 3.2 times 10 to the minus 2 on each other. What will be the force if they are moved so that they are only 1/8 as far apart? This is clearly a Coulomb's law question. Let's go ahead and start by writing that equation. We know that the electrostatic force between two particles is going to be equal to K times the magnitude of the product between the two charges. K, of course, is the constant of proportionality, 9 times 10 to the ninth, divided by the square of the distance between them. So we've got this very small force. The force is given to us as 3.2 times 10 to the minus 2, or 0.032 newtons. And then so the distance down here in the denominator is decreased by a factor of 8. It's reduced in size. I'm going to go ahead and draw some brackets here in blue around the kind of operative part of Coulomb's law here. So if we leave out the constant of proportionality, or we simplify this whole thing and simply assign them some kind of bogus numbers, if you will, that's 1, 1, 1, and 1, the value of our fraction then is 1, and the force is 1. And if we double the charges, then the value of the blue fraction, if you will then change. So for example, if I were to double one of the charges, then the value of this fraction would increase by a factor of 2. And we could say that if the value of the fraction is 2 on the right-hand side, then that needs to be equal to what's happening on the left-hand side. And so therefore, the force would be twice as large. We can keep playing this game kind of ad nauseum. And so therefore, we can change lots of different things. For example, we could double one charge and double the other charge. And then if we didn't change the distance, the force would change by a factor of 4 in this case, if we did that. So at the end of the day, it's important for you to kind of see these type of qualitative analysis, if you will, using Coulomb's law. This particular question specifically asks, what would happen if nothing changes? The magnitude of the forces didn't change, and the only thing that changed was the distance between them. So let's go ahead and rewrite this. We have K, Q1, Q2, over d squared, and now I'm going to increase the distance, decrease it by a factor of 8. So this becomes 1/8 of its original value. I have to remember that's also being squared. So if I go back to my blue brackets, if you will, I've got 1 times 1 over 1/8 squared. That becomes 1/64. I've got a complex fraction. And so the value of the blue brackets goes up by a factor of 64. They got closer together. So I'm simply, in order to answer the question, going to take the original electrostatic force here and multiply it by 64, which is the new increase in the force. And I'm going to get 2 newtons. 64 times 0.032 is going to give me 2.0 newtons is the answer to question number 6.